So good evening, everyone. My name is Arthur Cheung, and I am the Social Director of the UTEA Hong Kong, and I will be the MC for tonight's event. And it is my great pleasure today to have three distinguished guest speakers for this event to share about their views on today's topic: New Urban Mobility, Engineering Resilience for Cities of Tomorrow. In view of the current COVID-19 pandemic, not only it is important to build a city for faster pace of businesses, as we are all here through Zoom meeting, it is also important for us to become more resilient to ever-changing environment with new engineering solution. And the first speaker for today is Professor Yuen Leung, who is currently the president of Hong Kong Institute of Engineers. His professional engineering experience has been involved in the public health engineering sector in Hong Kong with more than 3 decades of experience. To start off the seminar for tonight, may I now welcome Professor Yuen to give us the opening speech.
Good evening from Hong Kong and good morning to all of you if you are joining from Canada. Give me great pleasure to be here with you today, the first time for an online seminar across time zones and collaboration between organizations in Hong Kong and in Canada. Let me first extend my sincere thanks to the organizing team to make this event a success. It's not easy. In recent time, as Harvard said, we have witnessed the COVID-19 giving a disruptive impact on the way we live and move around, on cities and society as a whole, and have imposed the worst impact to all economic sectors. Against this backdrop, the urban mobility faces two challenges. Consumer behavior and attitudes have shifted, and disposable income has shrunk. Social distancing practices, along with fear of the close physical contact, become inevitable. And it is a duty for us to build upon, among other key factors, towards a new urban mobility ecosystem. And no doubt that building such a new urban mobility requires collaboration among all parties. It is particularly important for engineers to contribute their professional knowledge and maintain close ties with other industry and the government. Also, engineers who stand at the front line of these can provide constructive suggestions and feedback on where the future of our urban mobility would look like and should be leading to, how challenges could be tackled, and how balance could be found. In today's webinar, it will outline how engineers' innovation can be realized and applied even in the most difficult time. We will learn how young engineers may also contribute to innovation with new ideas for traditional engineering applications. We hope to provide young engineers insight into what they can achieve to build a global society of boundless innovation, creativity, and economic prosperity. So a bit of PR about HKIE. As a professional body representing the engineering profession in Hong Kong, the HKIE is founded in 1947, incorporated under the Hong Kong Institution of Engineers Ordinance in 1975. The HKIE has 73 years history promoting the advancement of engineering within Hong Kong. Throughout the years, the HKIE maintained close collaboration with engineering institutions around the world. In 1999, Hong Kong became a founding member of the APEC Engineer Framework. The institution is the founding member of the Engineers Mobility Forum and the Engineering Technologies Mobility Forum, and is an affiliated member of the World Federation of Engineering Organization and a member of the Federation of Engineering Institutions of Asia and the Pacific. Besides being one of the signatories of the Washington Accord, Sydney Accord, and Seoul Accord, are also marking HKIE's close relationship with the education institution worldwide, including Canada. So a bit of promotion on the innovation within HKIE. The theme of the HKIE for the session 2020-21 is Believing is Seeing, Innovation for Transformation. In Chinese, it is 相信可看見，創新成蛻變. We intend to establish a new innovation hub, or so-called the Engineers Hub, that will stand to inspire current and future engineers of all ages and facilitate them to bring their ideas into reality. Our vision is to draw from the combined talents and experiences of all our members. We have over 35,000, and create a roadmap that will clearly show where members can go for funding, support, and assistance in realizing their ambitions. Actually, Hong Kong government has set aside a lot of billions of dollars to aiding engineers or young people to venture into innovation. But there are a lot of bureaucracy there. So Hong Kong IE is going to help our members to unleash the idea and make it into reality. So HARE will also be aiding members in grabbing such opportunities seen in the nearby Greater Bay Area with renowned immense innovation-driven development. So last but not least, I wish the event could serve as a contribution to the construction of a smarter city, that is, a resilient urban dwelling that provides its residents convenience, clean, efficient, safe, you name it, an environmental friendly living and working space. Thank you very much. Thank you.
Thank you, Professor Yuen. And for our next speaker, we have Dean Christopher Yip from Faculty of Applied Science and Engineering at University of Toronto, who is here now on the other side of the globe at Toronto to deliver a speech. Dean Christopher Yip is a leading scholar in the field of single molecule biophysics and a faculty member with the Department of Chemical Engineering and Applied Chemistry, the Department of Biochemistry, and the Institute of Biomaterials and Biomedical Engineering. And there you go, Chris, the platform is yours.
Thank you, Arthur, and thank you everyone for the opportunity to be here tonight. It's a terrific opportunity, and I'll say good morning to any of my colleagues who are here in Toronto as well. For those who I have met, as Arthur introduced me, I'm Professor Christopher Yip. I'm the Dean here at the Faculty of Applied Science and Engineering at the University of Toronto. I'm honored to welcome you to this exciting online event. I want to thank all the organizers, the Hong Kong chapter of the U of T Engineering Alumni Association, the Hong Kong Institution of Engineers, and the Smart Cities Consortium. Of course, as I was talking to Henry earlier, I would love to be in Hong Kong right now to deliver this. I miss the city. I miss visiting. I think I was last there in, I think about a year, November, almost a year ago now, 2019. But I do think that the format of today's event is really symbolic of the way that engineering as a community has responded to the recent changes in the world. We always do what engineers do well, which is use our expertise and our knowledge to design new solutions, innovative strategies to address unprecedented challenges, often, as we're seeing with the pandemic, on things which are extremely ill-defined, constantly changing, and constantly challenging us with new perspectives and new facts. And we need to adapt. And as all of you know, engineering is all about optimization in the face of ill-defined problems and challenges. So when the pandemic hit, and I guess you're in your third wave, we're starting our second wave in Toronto. And as it continues to impact us, we at U of T Engineering have drawn on our leadership in technology-enabled learning to pivot all our courses to online, to get ourselves ready for online assessment and thesis defenses. Our experts, which include actually our students as well, provided insight to the media, to the government, the emergency bodies as they started to respond to this unprecedented crisis. It's intriguing to see how quickly, in fact, a number of our students pivoted their really cool ideas and started to address things, whether it's an online platform for COVID tracing and doing heat mapping, whether it's strategies around mask design and fabrication. I'll throw it in the chat, but I'll refer everyone to our latest impact report, which really details a number of our really cool innovations in this space for addressing the pandemic. Our innovative research continued, and in many cases, new applications were found for work that our faculty members were doing and allowed them to pivot to address the challenges of COVID and the pandemic. For instance, our AI center, CART, develop new tools to help in the deployment of healthcare workers, best ways to position healthcare workers into affected areas. And we're continuing this nimble approach by developing even stronger partnerships across all of our divisions. As Arthur mentioned earlier, I'm part of the Institute of now Biomedical Engineering. We got rid of the second B, but we have always had a really strong tie with the Faculty of Medicine. We're developing new ties with the Faculty of Public Health. And this is actually an interesting perspective because I see that engineering is really going to be so critical, as was mentioned earlier, to helping get the world back out of this pandemic response. All areas of engineering will be able to positively impact this. So in a few minutes, Henry's going to share with you some of the fascinating ways in which crisis can lead to opportunity. When the old system, when any system is disrupted, innovation is there to fill the gap, and technology will help us repair, build it back in a much stronger, more resilient way. And I think resilience really is the key term to use here. And this is true whether the challenge is in climate change, better transportation networks, or leveraging the power of AI to improve lives around the world. And it's really not a coincidence that smart cities sit at the intersection of all of this. Today, a little more than half of the world lives in cities. By 2050, it's more likely 2/3. And so designing smarter, safer, more sustainable urban areas, more resilient urban areas is really critical to ensure a bright future for all of us. And as many of you know, one of U of T's, the University of Toronto's priorities is really to leverage our urban location in the heart of Canada's largest and the world's most diverse city. You may have heard of our School of Cities initiative, which is an outstanding initiative across the entire institution, the world's first intra-institutional initiative around cities research. And of course, in engineering, we have the Transportation Research Institute led by Eric Miller. So as we prepare our next generation of engineering innovators, leaders, and entrepreneurs, we recognize that our graduates must carry a global perspective and be comfortable working across cultures. I'm happy to announce that actually in our incoming class, even though they're not all in Toronto right now, we have representation from over 59 different countries, which is amazing. I'm pleased to report that more than 20% of our students will have an international experience before they graduate. I'm trying to make it my personal mission that 100% of our students will have an international experience before they graduate to really bring that perspective to the world. So tonight's event really brings all these topics together, and that's why I'm really pleased to be here with you. I'm looking forward to how Henry's talk is going to give us some new ideas, some inspiration from new strategies and for collaborations. And I just want to remind everyone, U of T Engineering remains always open, even online, for collaborations. Looking forward to partnering, if anyone's interested in partnering with our world-leading researchers in areas of technology, taking on our students through the PY co-op program. Maybe you actually have cool ideas for fourth-year design or multidisciplinary capstone projects, and we're happy to talk to you about that. So anything you need is available, of course, online. So please feel free to visit us online on the web to pull more information about that. So again, thank you for taking the time to be here tonight. I'm pleased to be here. I look forward to the talk, and I wish everyone a wonderful evening. So I'm going to turn things back, I think, now to Arthur.
Thank you, Dean Christopher Yip. Last but not least, our last speaker for tonight is Henry Cheung, who is the Managing Director of KONE Elevator Hong Kong. And he has over 30 years of experience in railway engineering industry and renowned in local engineering community. Without further delay, may I have Henry here now for sharing his experience.
Okay, thank you, Arthur. And thank you, Professor Yuen and Dean Yip for your kind words. Interestingly, both Professor Yuen and Dean Yip are in the medical industry, may I say, renowned engineers helping medical practitioners in fighting various diseases, viruses, or whatnot. So they are contributing to the mankind. I pay my salute to both of you. Good evening and morning, ladies and gentlemen. It's my pleasure to talk a little bit about what I learned. Actually, it's a big pleasure for me to speak after these two renowned engineers. So it's a bit my first time, actually. It's my first time also to deliver a speech simultaneously across different time zones across the world. Interesting, and there's a first time, so there's always next time. Now, as Professor Yuen and Dean Yip has indicated, that the pandemic, the COVID-19, has brought about changes or brought about a new way of living to our daily lives. Now we are more concerned about health. We're more concerned about well-being. So this is now top agenda for most people around the world, I would say. But something very interesting is that people's awareness or people's concern about these pandemic, if you may, affecting their life, may change according to the number of cases occurring around them. So there's an up and down, and we can see that even people in Hong Kong, we are experiencing the third wave, and in Toronto, second wave or coming up second wave. So what we are going to do, or we should do, is be vigilant about events, similar events that may happen. So that means we are changing our way of living in adaptation to what's coming around us. According to studies conducted by the Department of Economic and Social Affairs of the United Nations, by 2050, that's about 30 years from now, 68% of the world's population will live in an urban area, up from about 55% in 2018. That doesn't include, if you look at the percentage, it's not just the percentage itself. The world population will grow from 60 billion to 90 billion. So there's about 50% growth during that period as well. So what we are looking at, it's about, in absolute terms, absolute numbers, 2.5 billion more people will be living in an urban environment from now until 2050. And well, by the way, there are about 34 mega cities over 10 million inhabitants around the world today. Most of them are in Asia. But that number by 2030 will be overtaken by Africa. So most of the mega city by then will be in the African continent. So what we're looking at is the distance between people will get closer and more people will be surrounding ourselves. And now we are living in an unprecedented time. Everyone is wondering, okay, now everyone talks about a new normal, a new way of living, safe and clean environment. As an engineer, we all should be able to contribute to society with our expertise. How do we bring about changes to the public so that when they, let's say, visit a new place, they are safe and they are well protected from any harm, any viruses, any diseases, anything that may affect their health and well-being. Now, on top of that, actually, if you look at today's engineering, a lot of innovation is now being led by the younger generation because they are more adaptable, they are more agile, they have new ideas, they brought about new ways of treating the way of living, their lives, and the way we interact. Like they use social media better than we do, older generation. And they are able to communicate in many other aspects, which the older generation like ourselves cannot. So the younger generation will be the leader, will be the leading these changes in the future. Okay, I'm new to Zoom, so bear with me on these changes. So I talked about the new normal. So you may ask, what is the new normal? How are we addressing this new normal? The new normal is our vigilance to keep ourselves safe and clean in public space, in any space. And this will be our normal routine, I would say, in our daily life. Everyone now will wash their hand regularly during the day. Okay, when they get home, they may change their clothes, and they may wear a mask when they are in public area. Maybe not so in North America, not so popular there, may I say. But there are other ways that oneself would treat the social distance, the way we interact with the others. And there are more concerns of touching public accessible surfaces, like in the grab pole in a train, on a bus, the touch panel of a lift, the handrail of an escalator, and so on. So even if you go to a coffee shop, okay, you may not want to touch the surface of the counter. So these are the things that change during this what we call new normal. And now engineers, we should be more innovative. So we should be looking at, okay, how do we do things to ensure that we have a seamless transition into this new normal? How do we do a painless adaptation to this changing era? I'm in the lift and escalator industry, but as Arthur said, I was in the railway industry. But now with this lift and escalator industry, we what we call the so-called the high-risk area. I'll be using examples in this industry to illustrate my points of how we shift into the new normal and how innovation can bring about changes to our daily routines. So, okay, a bit of history for this lift and escalator industry, or lift in European terms, or escalator or elevator in the North American way of saying it. Some references, if you do some research, Archimedes in about 2.25 millennium ago, in about 230 something BC, he built a human-operated, I think using slave back then, human-powered elevator. And since then, it was used in various locations, mainly in Europe, around the Greece area. The so-called modern-day lift was deployed in 19th century in the coal mines back then, lifting coal from the deep well up to the surface. So it was driven by steam engines. The first electric motor-driven lift was probably introduced in the mid-1800s, and the rest, as they say, is history. So now we are living in a place where you don't really see the lift and escalator. They're part of your life. They're transparent. And that means this is your daily routine. And you don't even think about it. So how do we stay safe in this environment? There are three aspects. Actually, maybe I backtrack a little bit. The lifts and escalator are the most utilized public space on Earth, actually. Some government announcements, actually in Hong Kong in particular, suggested that these areas are very high risk for transmission of viruses, germs, diseases, and so on. Because they can have airborne or physical contact transmission medium. So you stay in this area on a regular basis. So staying safe while using these equipment has become a growing concern for an average person. So how do we as engineers take care of these, the stakeholders of these equipment? Okay, now who are the stakeholders, by the way? Okay, normal user, you and me, use it every day. Going to work, going home, maybe not so in North America, but at least you use it in shopping malls or in apartment buildings. the operator and maintenance, operator and management company, the one who runs the building, runs the retail shopping center or the office tower, suppliers who provide the equipment to the operators and users, the service provider. What I mean by service provider are the maintenance and checking services providers. So they're maintaining the conditions of these equipment. And public at large. So anyone that is nearby these public space may be affected. So these are the stakeholders. These are the people who may be affected by these equipment or these solutions. So how do we offer support in a changing into this new normal? Now for user, okay, obviously, if I can walk into a space that I don't need to touch any button, I don't need to touch a physical space. So no contact, no physical contact. So that will be a touchless solution, either by wireless or by some sort of voice control or any other means. Okay, in the air or the space confined in this lifts, for example, how do we automatically clean and disinfect the area inside? So that will be able to reduce the airborne viruses or particles or substances. Minimize disruption. Okay, if I have access to the equipment continuously, regularly, without even thinking about it. Everyone experienced that in the morning time at the office building is that we have to wait for the lifts. So this is in particular in the Hong Kong IE headquarter building. There's always a long queue. So how do we minimize waiting time and travel time, as a matter of fact? So I stay shortest time and leave the space of so-called high risk. Less crowd. How do we minimize the crowd inside the lift to make sure that the social distance, the interaction between people are minimized? Improve security. People seldom think about it, but security is a concern, growing concern. How do we protect ourselves? Not just health or safety is also a concern. So both health and safety, so security improvements. For operator or for management company, so how do we minimize disruption? How do we ensure that the service are provided continuously? Centralized control and supervision. So I can be able to monitor traffic for the entire shopping center or the entire office building or the entire office or residential block in one central control room and be able to disperse crowds in the shortest time possible. So that will be some sort of concern of the management company. Energy efficiency. So how do we minimize the usage of energy? Providing a cleaner environment. For maintenance, for the service provider, how do we be able to pre-warn that there is a failure? How do we predict that there is a service required? If there is a problem, how do we do quick diagnostic so that we can return the equipment back into service? How do we dispatch the right technical staff on site to support these service? Or how do we do remote fault diagnostic? So that means we can reduce the number of people on site. So the most senior technical staff will be able to find the problem without even be on site in the area and be able to guide the junior technicians to fix the problem. So this is something that if you look at the 3 tiers, the user, the operator, and also the maintenance, if we work together and we provide a solution that we will be able to have a always available lifts and escalator. That's it was a dream, but then now it is a possibility, a reality. So the reality is, how do we ensure 24/7 services that will be able to connect it, that will be able to connect between the parties concerned, the stakeholders. So we need to start with a system, a piece of equipment that will be able to tell everyone, all the stakeholders, the status of operation, the status of condition of the equipment itself. For the technical service technicians, they'll be able to do, as I said, remote diagnostic. Now, we are able to use AI or big data from these continuously connected equipment to analyze where or predict where the failure may occur, or to understand where the failure would be and fix the problem before it becomes a major problem. It is very simple, and sometimes we are not able to grasp the whole idea or situation. Take for example, if the equipment is always available for use, now you will not be able to, as a user or as an operator, you will not be seeing the technician on site. So is that good or bad? So, to me, it's good because it helps, it says something that the equipment has been in operation, is in good order. And the technician is somewhat hidden from the scene. So with the advance of innovation, AI, big data, predictive maintenance, everyone talks about it. We should be able to do that. And we are doing towards that goal, very close to it. A lot of service companies are able to do this remote diagnostic now, data capture. In not so distant future, we should be able to do big data analytics on these equipment. For the user, so less breakdown, that means it's always available. That means they don't need to wait, or they don't have one less piece of equipment to worry about. So less crowdedness, less waiting time, shorter time in the lifts itself. So for managers, for operators, that means they can disperse the people waiting in the lobby in a much faster way, especially in high traffic area. So the operator may focus on more higher priority issues, like how to manage other aspects in the crowd control situation. Now, everyone has a mobile phone these days. It's close to 100% penetration around the world. Mobile app or online application is now a norm. It's again a new normal compared to like 20 years ago. In the past, it's like it's only a website. It's only something that would give you some static information. Now, with today's mobile application, we are able to provide with the technician, with the operator, real-time monitoring of the status of the equipment. Now that means the technician need not be on site, and they have eyes, which is through the mobile application, on the status, on the surface of the lifts and escalator. Now we're talking about 5G, implementation of 5G around the world. The 5G technology brings about the real-time monitoring of these equipment. So the stakeholder will be able to know the situation, again, in real time. For example, if there is an emergency on site, the coordination between the management company, emergency services, maintenance, and maybe even the media and the user nearby will be, a key So we need to have very good communication between these parties so that they are well informed. And if there is a person trapped inside, God forbid, the lifts, they can be calmed down, so they will not be in a panicking situation. So that means we are able to do things that is not possible in the past. That's on top of, if you look at the lifts today, we are able to stream commercials or other news information onto the TV inside. Now with 5G technology, we should be able to stream other information real time online that would give direct communication between the people inside the lift with the people outside. Okay, we were able to, for example, the control center may talk directly with the user in the lift, not just by voice, but also with real video, live video. And that would be a very good comforting factor for the people trapped inside. Another example is that the technician may be in another site, maybe, I don't know, in another building nearby. And they receive a message through this mobile application, the performance of another lift in another location may be at risk. Maybe there's some fault experienced. Then he can decide through the mobile application's advice, move to help. So they can be there in advance of a real problem developed. Also, if there are very difficult or hard to diagnose problems, the 5G technology or the mobile application may connect the on-site technician with the technical help desk behind. So the technical help desk can use augmented reality or virtual reality system to help the technician diagnose the problem and fault finding on site without being on site. So this is something that has not been dreamed of in the past. That is now made possible by the advance of technology. On, well, as I said earlier, on the people flow in the building, many of us experience a long waiting queue at various locations. Now with the COVID-19, people are more concerned about crowds, about people adjacent. You don't know if they are a carrier of the virus or not. Like in Scandinavia, actually, is in Norway, Finland as well, where KONE came from. There's a mandatory requirement to, even in bus queues or in waiting for lifts, you have to stay 1.5 meters with the people around you. So that means this is something that how do we disperse these huge crowds in a very short time so that they are not in a high-risk area again. So we should be able to do some planning ahead of time. In the past, 20, 25 years ago, we only talked about road traffic planning, road traffic management planning. How do we divert cars on the road faster so that they're not jamming the intersection? Or how do we plan a railway station or air traffic at an airport to divert the people so that they're not crowding a certain area? But today, we should be able to do the same for any space, any space. Take, for example, Olympics, if it happens next year. So how do we disperse 100,000 people from a stadium in maybe half an hour or 1 hour so that they are peacefully going away from the stadium area? Football games, like the backdrop behind me, it's like a Premier League's backdrop. So how do we, in football games or concerts or outdoor shows like firework, parades, or even as simple as a mega sale in a department store? It happens in one major department store every year in Causeway Bay, near Hong Kong IE's headquarters. So how do we disperse these people inside and outside the space? Okay, even in Hong Kong IE headquarters, now we have to wait in long queue to get into the elevator, or wait a long time to get, after the event, get out from the Hong Kong IE's headquarters, because the lift is always in use. In the past, the design of railway station has always taken people flow into consideration. So they have to look at how, when a train arrives, 2,000 people gets off the train, and everyone is hurried into the escalator or lift area, and then go to the concourse. Now they can be dispersed within 2 minutes, meaning the next train will come in about that time. So one example is Admiralty Station in Hong Kong, 8 a.m. So it happens on a daily basis. Now this concept is now applicable to even shopping centers, so office buildings, hospitals, and stadiums. So this is a mindset change. This is like, okay, are we applying something which is not designed to be applying to this kind of design? A mindset change, the new normal, if you may, again. From a pure capacity-based design, so in the past, when we designed a lift, we only calculated the number of residents in that building, or in the office, how many workers are working in that building, and divide by the number of lifts. And then we calculate, okay, the waiting time is so and so, 5 minutes, for example. So pure capacity-based design. Now, the architectural firms, developers, and consulting firms are doing something which is different. They're now looking at not just a static capacity-based design, but they're looking at dynamic design, where the people are flowing into and out of the building. And also recent months, we've been approached by some companies on how to manage the social distance as well. So these are the new things that may add a new dimension and complexity to all these requirements. So what we can do is use our expert knowledge, data, real-time data, real-life data, or just capacity-based data, and simulation tools, and our knowledge in converting or putting all these into an analytic manner. So these will be put into an algorithm and generates a model that we can measure how effective we can move the people from one place to another within a building or in an open space like a stadium. And that would also help in reducing crowding and also bottlenecks. Like if you go to a reception counter, the bottleneck will be there, for example. Okay, for these type of planning, there are three tiers that we may need to do to help the clients. The first level, the first part is statutory standards, guidelines, best practices, design requirements. These are the fundamentals of the requirement and also the constraints. So we have to understand how many people we can accommodate in a certain space. So that will be your maximum number. And the way how quickly we can move the people from one place to another, so on and so forth. So these are the best practices and constraints. And also we use our history or experience, data sets from the past. And that would help us in formulating not just from the best practices, but also forming a model that is workable. Okay, so we know from a certain stadium design that the other stadium may not be as user-friendly or cannot move the people in the same amount of time. So these are the issues that we have to take into using the data sets or our knowledge, experience. And the third aspect would be some sort of planning. So how do we use these data? How do we use the data and give the user, the one who will be using the space, the best user experience, both in terms of the user moving through the space and the user who manages the space. So these are the things that we should be looking at. And there have been many additional requirements as well. Like, for example, if there is a entry gate, a security gate, how would that affect the flow of people? So we need to look at the design. In the past, we do lifts, how many people we can carry in a certain amount of time. Now we are looking at the entire, for example, lobby and the entire building. How we move the people from one place, from the entry, through various locations in the open space or the area, into the lifts and to the destination. Okay, now this is one of my favorite slides. So what we are looking at is how do we measure flow in a building. So we look at the incoming and outgoing flow, the people that goes in and out of the space. So this is, try this, laser pointer. So this is the incoming and outgoing people flow. Now, we also look at, in the building, how we circulate people inside. So they may have a certain emergency exit, for example, a certain path they have to follow. How we move the people inside this area. The popularity of routes, everyone has a favorite route from entry. Like, for example, if I exit a certain railway station, I will be using a certain entrance into that building. Or I'll be using that particular route so that I can pass by a coffee shop to buy a coffee en route to my office. Or I have the shortest distance from the entry to the lifts. The number of people inside also affects the design, so population. Travel time, everyone, I have to emphasize, it has some sort of sentiment on travel time. So waiting too long for lifts, too many people opening and closing doors, stopping on every floor, and so on. So travel time is an issue. Elevator traffic profile, so how fast the elevator can go up and down, and are they stopping at the low floor zones, high floor zones, or all zones? If they stop by the car park, or they stop by the first floor where the coffee shop is. That brings into the usage and floor and area. So where do we locate the various utilities or the popular places, shops, for example? Equipment usage. How do we, for example, escalator, how do we configure them? For example, in the morning, if they all go up, and in the evening, they all go down. Or there are certain pattern that we divert the people to use a certain particular route. Also user experience. So how the user normally do their routine. So, and waiting time and dwell time, if they have to, let's say, for example, they have to stop by the security counter or the reception to get their pass into the building. Now, on the data collection, which I have to say a few words about, everyone is concerned about data privacy these days. So in doing all these planning, we need to somehow capture the flow of people There are many ways of capturing the flow of people. The most effective way is to use CCTV cameras. There are many others, like tracking the loading in a lift, or tracking the loading on an escalator. We can count the number of people entering the manual counting, the number of people entering a certain entrance and so on. But using CCTV camera actually we found to be the most effective way. Or sometimes some people who use the Wi-Fi or the mobile network to capture how many people are in the vicinity. Now, using all these tools, if you may have some sort of effect on concern of data privacy. People concerned about you track where I am. Okay, if my boss will know if I stop by the coffee shop every day before entering into the office and so on. With today's technology, actually, we are able to count the number of people and not capturing the face. So we know there is a person, but we don't know that particular person. So these are the things that are able to be able to so-called alleviate the concern of data privacy. And we also have software that tracks the number of the people, but not saving it on a file. So we are not doing recording. These are the things that are able to help, if you may. Okay. Now we need these data. We need the number of people through a certain area, so that we are able to understand where the people are and how we can streamline the people flow. Another thing about this is that, take for example in the hospital, the doctors may receive a priority call. He may need to attend to a certain emergency. Now, how do we, in the people flow, how do we take this priority into consideration and treat that call as a higher priority than the others, and not affecting the general flow of people? So that may also help in the design of hospitals and the number of equipment inside the hospital, and how to maximize the utilization. With all the data captured, so we entered into a software tool. Data collection is always the first step, and with the data, we cannot do anything about it. We don't know how to deal with it. So we need to put it in some sort of model, and from that model, we derive a solution. So with the today's processing power, actually, we are able to do the software algorithm very close to real-life simulation in almost real time, I would say. So, you know, we're able to, in the past, we have to run the simulation like days on end, and then come up with a scenario the next day. And that will only be, you know, that's the past. That will only be possible with the older generation processing power. Today, I would say even our mobile phone are able to achieve a simulation in no time. So actually, with this simulating scenario, we are able to deduce where the pinch point, the bottleneck is. I use an example, again, a coffee shop. Actually, I cannot disclose the name of the client, but then it's a bank in Hong Kong. We help them in, they have some problem. Some of their very top senior staff, they were not able to enter into a lift in the morning. And he sort of complained to us and saying that our equipment is no good and so on. So, okay, what we did for them was, okay, we look at the flow of people using this data capture and doing some simulation. And in fact, we found the bottleneck to be in a cafe. Actually, they put the cafe on the 6th floor. So at about 8 a.m. to 8:45, everyone will be going to the 6th floor. So all the lifts will be stopping on the 6th floor, buying coffee. So we identified the bottleneck, and we asked them, okay, if you move the coffee shop to another zone, which is on the low floor, and using the low floor lifts serving the coffee shop, the whole problem went away overnight. Okay, so that means we are able to identify these quickly and derive a solution and help the client in tackling their maybe not so obvious problem. Now on to the innovation. Now this is again something very to my heart. With the pandemic, with the COVID-19, everyone is concerned touching the buttons of lifts. So, you know, people use toothpicks, your car key, the mobile phone, you know, a piece of a napkin to press the button. Okay, so some of our younger engineers, actually this is done with the young engineers, led by the team. Actually, the team comprises of different generations, but it's led by the young ones. We train them a little bit on the so-called design thinking, the pain points and the of the user and so on. So they were able to come up with quickly with the solution. So this is something that they derive using QR code that they are able to implement quickly within a month. Actually, this is something maybe I'll talk about in a minute. Within a month, and deploy that in as a trial in our office, and then it was deployed to one of the residential building in Hong Kong. So there are two types. One is the so-called hall call, which is the external call. The external call comprises of two things, just the up and down button. So that's easy. So we don't need to use QR code at all. So up will be waving upwards, down will be waving downwards through the camera. So that will be the up and down call. But inside the car, you have to press the button, the floor you want to go to. So then you need the QR code. The code actually itself is the floor number. There are many ways. Well, then people may ask, okay, we have to install a QR code generator on my mobile phone. How about the the seniors? They're not able to do this quickly. How do we do that? Easy. Two things. One is we have all these QR codes as a picture posted in the lobby, so they can take a picture of the only two floors they need is the floor of their home and the ground floor, most likely. So two pictures. Or we give them a card, which is the QR code itself, like this, a card with, let's say, on the 11th floor. So this card is for 11th floor. That will be the home card. And if they want to go out, there's a ground floor card. So two cards is all they need. So many ways we're able to achieve that pressing a button without too much hassle with the technology. Also, this is an example of a multinational company. We belong to a large corporation. A large corporation with this R&D will take 2 years or 3 years to complete. So no way we can do it within a month. So what we did was we worked with a local startup in collaboration with them. So they provide the agility. They provide the quick turnaround. We provide them with the resources. We provide them with potential for trial. So big corporation and startup works perfectly together. So this is an example, perfect example of how we should, as an engineer, think of ingeniously solutions to help everyone. So apart from QR code, we have many other technologies as well. QR code for one, voice control. Actually, we tried in Hong Kong. We have English, Cantonese, Mandarin, we have Shanghainese, we have Chiu-Chow, we have all kinds of dialects. So we try them. There's an AI engine behind. So we capture the voice call and then translate that and store that into the database. So after a few trials and the AI engine trained itself, so we're able to capture quite a few dialects, which is quite amazing. Again, this is led by young engineers. In fact, it's done by one young engineer and 2 interns, who is even in university. So a collaboration again with universities and ourselves. So we have also infrared solutions, and we have proximity sensor. And we also tried Wi-Fi or mobile data, but sometimes in the lifts, we are not able to receive Wi-Fi or it's not installed with the antenna. So these are the most popular solutions available. Now on another thing is on escalator. So we need to disinfect because everyone has to hold on to handrail actually. So how do we ensure safety where, this is the highest risk area? You don't know who touched the handrail before you. So this is again a collaboration of ourselves and a small SME actually, a small company locally. In fact, the technology was not applied to the handrail. Actually, it's done. They use it's a nanoparticle solution, and they spray it in the area to disinfect for disinfection. So we tried that and applied that to the escalator handrail, and it works quite well actually. So again, this is a collaboration between a large corporation and an SME. So we leverage on each other's strength, and sometimes we apply a solution which is not designed for even escalator, and apply that, and it works quite well there too. So there are many existing handrail disinfecting solutions. The most popular one is a cleaning lady standing there with a piece of cloth cleaning the escalator handrail. Works very well, but you have to wonder how often they clean the cloth. So this is, and also you have to hire someone stands there all the time. Not very good. Another thing is they grab this. This is a cloth with a sort of a clamping device, clamp onto the handrail. This is good as well. It eliminates the physical person, but then there's a finger trapping problem. If a small kid comes around, so this will be trapping hazard. By the way, the BBC also reported studies. There are many solutions using ultraviolet cleaning agent. There was a BBC report that studies show that the ultraviolet cleaning is not very effective. In fact, it was the World Health Organization warned against the use of ultraviolet for this type of cleaning. So, but these are the people's preference for the time being. Okay, the importance of young engineers. Now, they are energetic, they are insightful, they bring in new ideas. So we are very much, in the sort of old generation in collaboration with the young generation. So we are looking at how we leverage on the knowledge they have, the young engineers, to help us gain the some leading edge into the next era, into the new normal. So the examples I gave earlier prove to be very effective. So young engineers, they are energetic and they are enthusiastic to bring in new ideas and bring new solutions into reality. And we are always in debt of to the society. So we have to train the next generation. we are a corporation of over 100 years old. We have to sustain ourselves into the next 100 years. How do we do that? Young engineers is the only solution. And we have to make sure they are happy. They are blending into the corporates, into as an engineering mode, into innovation mode, so that they bring about new technologies into reality. I said earlier, we partner with startup, and we partner with them around the world. So large corporation and startup have two different angles, have two different, brings two different types of benefit to the table. And a collaboration will leverage on the resourcefulness of the large corporation and agility of the startups. Okay, before I close, I should thank Dean Yip, Professor Yuen, University of Toronto, Hong Kong Institute of Engineers, University of Science and Technology. There are many alumni from there attending. Smart City Consortium and KONE Corporation for allowing me to speak tonight. Thank you very much. Over to you, Arthur.
Hi. Hi, everyone. So right now we'll be in the Q&A section. So you're feel free to have your questions on the message box, and then we'll have our speakers to address for the questions. Okay, so I think the first question is addressed to Henry. So can you read it, Henry?
Sorry, I have to. Okay.
Okay, so I'll speak up for the question. So the first question is, was the touchless solution applicable for all types of lift?
Well, the touchless solution actually is applicable to all lifts. As long as you have a push-button panel, it's applicable. So this is retrofittable to any lifts around the world.
Mm-hmm. And for the next question is also addressed to Henry. So it says, are there any emerging IoT as well information and IoT means KONE is used?
Yes. Well, actually, we are using. Can I say that? Maybe I can. Yes, because we team up with the Polytechnic University. They have very innovative fiber optic solution as a IoT device. So we are applying their technology into our solution. We are in collaboration with them at the moment.
Actually, I actually have one question for Christopher. So actually, when Henry was speaking about the 5G technology, will bring changes and disruption to what has been 3G to 4G. So as you can see, 5G is going to come into play in the future. So since, for example, you will be in the biomedical field or in your own specialty. So what would you think in the coming years that the 5G is going to bring? What kind of changes for the engineering or in the fields that you specialize in?
Oh, I mean, I think you raised a really interesting point, because all these technologies, the ability to get data wirelessly, be able to interconnect, the whole IoT of things, it's going to be huge in the medical field. It's going to be sensor technology, the ability to monitor, health conditions in the hospital context. I think an important one right now, even in the pandemic case, was how do you do remote monitoring of patients who are ill so that you're not exposing healthcare workers to those conditions, right? So actually early on in the electrical engineering group, actually developed wireless technology for doing pulse ox monitoring of patients in long-term care homes so that you could do that. So that's without 5G technology, but that's clearly where those sorts of things are going to come down the pipe and make it a lot easier. So I think that's one area where there's going to be an immediate impact of that. So does that help?
Yeah, thank you. So let's say, next question.
Yeah.
I think it addressed to like Professor Yuen. So I would say, how to solve the generation gap between the young and experienced co-workers, or like experienced engineers, I suppose.
Professor, you have to turn on the mic.
Is it all right?
Yeah,
Yes.
Yeah. I think you have a very valid question. I think it's always young and the parent, for example, it's difficult to communicate these days. And these youngsters only communicate through the through the social media. But I think as an institution in Hong Kong, we have over 35,000 members. I think certainly we have created a platform whereby engineer, no matter young or old, that will come together to work together for the betterment of the engineering profession. And we encourage interaction between the youngsters and more mature engineer within each divisions. So we actually have fostered a more collaborative arrangement for youngers to be participating in the division's business and all these. But of course, within each organization, we are supporting for nurturing of young engineer. We have various types of training schemes, scheme A training that would help and also assess making these possible for organization to nurture young engineering and engineers, and at the same time, we want them to go together and of course become members of the institution. So we also have a young members club, so a committee within HAID, which is very strong, and they have very strong participation in the institution's business. So I think all in all, we are actually mingling all the young with the mature engineer within the platform of the institution. But one thing I want to supplement is about the Dean Yip, about the earlier question about the future of 5Gs. I think in Hong Kong we have a very ambitious hospital infrastructure development plan. We have the 10-year plan. So basically, the amount of investment would be amounting to 500 billion Hong Kong dollars. So it's literally we have to turn down all our older hospital and build new one, and we develop new ones. So in that development, we have debate on whether we put in 5G network there. But there are school of thought by saying that we don't know what will be the development of this 5G. Are we going to say building such a network because it requires a lot of chunkings and all these, because of the penetration would not be that easy through walls and all these people saying that. So, but after debate, we still believe that 5G is our future. So we literally build all these 5G network, even without knowing the application. We build the network there first. That is one thing. Upon the COVID sort of handling of patient, because of avoiding contact with the medical staff, we're promoting less contact of the patient, confirmed patient with our medical staff. We are actually venturing into telemedicine. So as Dean Yip said, we actually have a lot of pulse measurement, temperature measurement without physical contact. So they measure their own, and then through the wireless, and then with all this information pulled into a central system so that the doctor can see it. And actually we have the video sort of meeting with the doctors. And that because of COVID, that forced us to go into that sort of resolution. And the outcome will be very good. Actually, I think people are more receptive than what we expect, because in those days, people just want to have face-to-face meeting with the doctors. But because of COVID, the side benefit is we are promoting a better sort of wireless and telemedicine. So that's my supplement to that question.
Thank you very much, Professor Yuen. So our next question is to Henry. So as one of the leading innovative companies, can you share how KONE differentiate itself from the other elevators company?
This is a very interesting question. I should not be downgrading my competitors. But being a Finnish company, so we are close to Nokia. In fact, the headquarters are very close by. So innovation is in our blood. So what we do is we develop a lot of new solutions. Something that is maybe, I would say, 2 steps ahead of us. So we talk about touchless solution. We talk about QR code wireless or whatever. In our R&D team, we are talking beyond that. Okay, something well ahead. I cannot disclose too much, but something that is not even touching. Okay, so we tried eyeballing. That one I can talk about. So you look at the floor, and then the button is pressed, something like that. And then we developed a platform and the lift as a platform. So open to all. You can write application to not controlling the lifts, but then I don't know. Now you can have commercials in the lifts. Maybe you can play video game, live video game. The 4 walls are your the gaming platform. That can be done. Actually, it's trial. We have that platform available. So these are the things that we are looking at. So innovation is in our blood, and that we differentiate ourselves from the others.
Well, thank you very much. I will be very happy to try some new games on the elevator.
You need to write the code first.
Yeah. So the next question is also to Henry. So the question is, what is the future of in-building people mover system over the 5, 10, or even 50 years from now on?
This is a very interesting question, and in fact, maybe I should split them in 2 parts. One is the so-called APG, automatic the robots. In hospitals, in hotels. So we have robots that delivering dinner or delivering medicines to patients. So this is already in place. So the robot will be interfacing with the lift system. So it's automatically pressing a button to the floor the robot needs to go. So that is already done, and a solution is available on the market. Now, maybe that's the today part of the people mover. We can convert the robot into, for example, hospital bed. For example, we move the patient from his room to the operation theater. That today we have to physically a nurse or the armor will push the bed through the maze into the place they want to go. Maybe in the future the bed will have 4 wheels or motor. I don't know. So the bed may move by itself, just like a robot, to the place that the patient needs to be. So that's today technology. In the future, maybe I don't know. The lifts can be removed completely. So there's a little box that people, even your seats in your office, can be converted into a lift car. So you press a button, your chair will bring you to the next floor to see your boss, something like that. That is also achievable and is trialed successfully. But whether it's useful, okay, wait to be seen. We don't know if that's a good application or not. So two things.
Okay, and so for the last question would be, is to Henry, but I think this question maybe can address to Professor Yuen as well, because I'm a civil engineer and this is something related to BIM, Building Information Model. So it's like, they say, hey Henry, are you adopting BIM and design for manufacturing and assembly for lift design and site installation in Hong Kong?
Maybe Professor Yuen, you want to answer that first?
Your answer first is about lift installation.
The short answer is yes. In fact, because the hospital authority and other major end user, everyone is adopting BIM as a standard, as a basic requirement. So everyone is now adopting or using BIM as the basic requirements. So the short answer is yes. But the longer answer is there's more than just manufacturing and assembly. And we are also looking at other interfacing design as well, and also for maintenance, maintenance data, whether the BIM we can adopt in the grand scheme of things, not just for the preoccupation phase, but also for the operation phase for maintenance as well.
Yes, so I can supplement a bit because BIM normally people talking about for handling construction works, so that there are less conflict and things can be built in a more efficient manner. But the point is that that beyond that, we are talking about the so-called asset management. So under that sort of things that, for example, in hospital, we're looking for using BIM for sort of emergency management, because that BIM can tell us, actually can show us if we build a system that would enable us to know when we shut down for example, a switch, we know which area is being affected. So that would help us to diagnose the problem, know the areas being affected. That's one aspect. The other one is about predictive maintenance. We can put in IoT to spot check on some of the things that of the plant, physical plant, and with that sensor coming back to the BIM drawing, that would show us which component or which plant are actually having over temperature, over pressure, and all these. That will help us to our tradesmen to know to predict or forewarn things are going to happen, and that would maintain the ongoing 24 hours operation hospital, because interruption is the worst thing happen in Hong Kong in hospital setting. So we are patient there. They need us to support around the clock, and at the same time that could extend into so-called simulation, like the sort of data gather for lift, for traffic, for patient flow, and for supervisor flow. Then help us by then, if it's hooked up to the lift system, they can help to drive the lift to what people want. That would improve the safety, sort of efficiency. So a lot of things that can build around BIM. It's not just purely drawings. If we put this drawing attached into data, even online real-time data, that many things can be done by the system. All right.
Oh, thank you. So we have two more questions. So the next question is also to Professor Yuen, and maybe also Christopher can take part in it. So it says, how will HKIE collaborate with other engineering associations, such as UT Engineering Alumni Association, under your theme of innovation this year, so that the knowledge from engineering professionals graduated around the globe?
So I think we actually it's not actually directly with the university. It's actually nationwide sort of collaboration, because a lot of countries are subscribed to Washington Accord, and the Washington Accord will have specified attributes for undergrad. So basically, if you are your country and even the university accredited to Washington Accord, so your degree will be recognized. by Hong Kong. And through sort of practical training, you can apply for membership as a Hong Kong IE member. So I think basically we are connected through this. But of course, we have chapters in different countries. So you can join as a sort of a graduate member or whatever members that with the chapter in Canada. We have chapters in UK, in Australia. So there are some linkages locally with the HKIE back in Hong Kong. So that is the sort of things that I can tell you about it.
Yeah, I mean, especially for Chris, maybe like in the future, like is there some engineering problems or engineers that want to come to Hong Kong, you can just go to Hong Kong IE and it will be such a great platform, and we as a UTEA can also take part in it as well. Because so the next question, or I'll say almost the last question, would be, oh, sorry. Sorry, my email. Oh yeah. So is to Professor Leung and Dean Yip, so what are your views on how to best nurture and attract young minds, especially young women, to consider engineering as a profession and be attracted to engineering? And how is U of T going on about this?
Okay, so you ended with how's UT going to go about this? So let me I'll start with that. The especially for, I mean, engineering as a field is hugely attractive, and I think our approach is actually to showcase how broad engineering's impact is on the world right now, right? Within U of T engineering, our intake of women into the program is actually close to 40% of our entering class are female. And so that sort of shows you, I mean, actually, previous year was actually 42%. This year, it's just under 40%. So we're a diverse, a culturally diverse faculty, and providing a huge number of opportunities for students to really explore their interests in kind of the core engineering, but also other areas. So getting students in who are interested in engineering, but also public policy, interest in different minors, different areas, and allowing them to blend those interactions and work as part of their degree, and to showcase really that, you know, the engineering has some really, you know, core technical things, but we're also, our impact is much broader now. And I think that's one way to attract people to engineering as a field. We're showing how engineering has been so critical in the pandemic response, right? As Henry was showing, all these issues about people movement, that's, you know, that's operations research, all the areas around electrical engineering tied to motion controls inside your elevators, you know, that's 3G, 5G, all those different technologies. This is where engineering is going to have a huge impact on the field. We're seeing how engineering is impacting the healthcare field. Engineering is critical to supply chain right now, manufacturing. We've seen what happened when manufacturing supply chains get shut down because countries get blocked because of the pandemic. And now you realize, how do I rebuild these supply chains going forward? So showcasing that kind of impact is one that'll draw students into engineering. We're extremely proactive about encouraging a diverse cohort to come into engineering, drawn from different regions of the world. We want a global community inside engineering for sure. So we're increasing our draw from other countries to make sure we have a diverse community. And that includes as well hiring faculty who reflect the community that which we serve.
Yes, from Hong Kong, from the institution, Hong Kong Institute of Engineers, we try to attract youngsters to join engineering, become engineers in few fronts. I think first of all, we try to promote the standing or image of engineers. So recently, I'm a hospital engineer, so whenever there are interviews on media, I will come out, and then that will help to promote the image of engineers. But of course, by doing that, we let the public know aware of what engineers have been doing. That will help attracting some of the parents for guiding their children to join engineering. But at the other end, we are very proactive, as Dean Ip said. We actually try to formulate as student ambassadors. We have young engineers to go to talk to secondary schools and even the primary school. Now we go into kindergarten as well. So with all the events, we also invite these schools, kindergarten, to join our activities. So when they are very young, we tell them what actually engineers have been doing. And then at one time, actually, when I have activities with the secondary school student, some of them they don't know about what engineer actually is. Surprisingly, one student told me that she didn't know how to draw, how to build things. She asked, could I be an engineer? I asked her a question in return. So do you know how to play games, TV games? She said, yes. So I think it's a hard way to become an engineer. You know how to solve a problem. Playing TV game is solving problems. So I think you're halfway to become an engineer. So she said she will study engineering. But of course, on the other end, about women in taking engineering, in Hong Kong IE, we have a women in engineering committee. So we have all ladies joining them. A lot of ladies participate in this committee. And the sort of problem they have identified is most of the ladies, they actually, after getting married, they get pregnant, they have to raise children. So they're trying to look into a way that part-time will be a way out to retain those women as engineers. So some of the things are happening. So we try to promote the women in engineering in the institution. So that's the work that we have been doing all the time.
Okay, so I think that would be like the wrap up for tonight, and also just as the MC towards the last question, I think other than like women in engineering, like I think currently the society is taking a role on like the STEM education, how to build an education system to get people more involved in the engineering industry as well. So. So I would like to sum up, like, thank you, Henry, for your sharing on this topic and your experience, and Professor Yuen and Dean Christopher Yip for taking part and then giving your insight about today's event as well. So and to all attendees, thank you very much for participating, and hopefully in the future to take part in more HKIE and the UTEA events. Thank you very much, everyone.
Thank you.
Good night.
Everyone.
Okay, good night. Thank you. Bye.
Bye.